Hi, geometry students. We're going to start 3-6 perpendiculars and distance. It's a pretty heavy section, so I'm splitting it up into two parts. In this part, you're going to find the distance between a point and a line. And the one thing you need to know is distance between a point and a line. The distance between a point and a line, or a point not on the line, is the length of the segment perpendicular to the line from that point. So this is what we need to find. We need to find this segment that is perpendicular to the line. That's our main goal. So if we're looking at this figure, construct a segment that represents the distance indicated. So we're looking at Q to the line RS. Now remember, the distance has to be a segment perpendicular to the line. So can we construct that? Can we construct a perpendicular segments? Of course we can. Okay, we can form this line here, and if we extend this line here, we can create a perpendicular angle. All right, so that's what this type of problem is looking for, that represents the distance indicated. Now you need to have your packet out, and you need to write down this postulate, the perpendicular postulate. If a given line and a point not on the line, then there exists exactly one line through the point that is perpendicular to the given line. And you need to draw this picture. You can pause the video at any time to copy this down. So what we're going to do now in this part of the section is we're going to find the distance from P to M. Now in order to do this, we are going to use things that we have used in this chapter and in algebra and also in chapter 1. So remember, in order to find the distance, we need to create a perpendicular line segment and find the distance of that line segment. So here are the steps that you're going to need to know. I want you to pause the video and write this down. All right, these are the 4 steps. First thing you need to do is find an equation for line M. Then you need to find a line perpendicular to M containing P. Then you need to solve the systems of equations to find the point of intersection. And this is from algebra. And when you get to class, we are going to practice systems of equations a little bit more. And then we need to find the distance between the intersection and the point. So step 4 we did in chapter 1, and you just did it on your term test. You guys did a fantastic job of using the distance formula. So that's going to come back. So let's begin with our first step. So we need to find an equation for line M. Line M contains a slope of 1 and a point 0, -3. Can we find an equation for that given information? Well, we have a slope and we have 0, -3. So this is going to be, and I'll add the comma here because that's bugging me. So if we have 0, -3, this is an intercept, isn't it? So we are going to use slope-intercept. So the equation of our line then is going to be, and I'll write it in red here, y equals 1x minus 3. Or we could just write y equals x minus 3. All right, so that's the first step. We did that. Great. The second step, find a line perpendicular to M containing P. Now this was like the quiz that we just took, number 6. So if we have a perpendicular line, what are the slopes again? That's right, they are negative reciprocals. They are negative reciprocals. So if our slope is 1, what's the negative reciprocal of 1? If we have, our new slope is going to be what? well, if we have 1, and I'm going to do my scratch work over here, we flip it, it's still going to be 1, and then we make it negative, it's going to be -1. So our new slope is -1. So now we have a slope, and we have a point and a slope. What are we going to do? That's right, we're going to use point-slope form. So write down your equation for point-slope form. Let's go ahead and find out what our new equation is. So we have y minus 3 equals a -1 times the quantity x minus 4. I want you to pause the video and finish writing out this equation in terms of y equals. So you should get y equals a -x plus 7. So that's the equation of our new line. So now we have the third step. This takes us back to algebra. Systems of equations. So we have to solve the systems of equations to find the point of intersection. So our equation was y, oops, let me fix that. Okay, fix that. So now we write the equations here, one right underneath the other. And remember, with systems of equations, we want to cancel out a variable. So what do you notice that cancels out right away? The x's cancel out. Positive x and a negative x, that's going to cancel out. And then we have y plus y, that's going to be 2y equals a -3 plus 7 is 4. So what's y going to equal? Y is going to equal 2. And what we need to do to figure out what x is, we got to plug that back in. So I'm going to plug that back into our original equation. So we have 2 equals x minus 3. We add 3 over, x is going to equal 5. So our point is 5, 2. And our original point that we started with, point P, was 4, 3. So now what we're going to do is find the distance between these 2 points. And that's going to be our fourth step. Very, very long problem, but totally worth it, right? So we're going to find the distance between the intersection and the point. So I want you to pause the video and write down the distance formula. Okay, so I went ahead and plugged in my values. So when we do this, we have 5 minus 4, which is 1. We have 1 squared, plus 2 minus 3, which is a -1 squared. Remember, this is all underneath the square root. So 1 squared is 1, and a -1 squared is 1. So our distance, our final answer, when it's all said and done, our distance is going to be the square root of 1 plus 1 is 2. So that is our final answer. Make sure you guys are writing down questions, any concerns that you may have. We're going to practice this quite a bit, but it's kind of just piecing together everything that we've done in this chapter, a few things from last chapter, and a few things from algebra. I really want you guys to write those things down. If you want to practice this just a little bit more over the weekend, page 221, 17, and 19 are great practice problems, and they're odd if you want to check. But like I said, please come with questions, and I hope you guys have a great Friday off and a great weekend, and I look forward to seeing you on Monday. Bye guys.